Okay, so on Friday we started talking about the mean value theorem, right? The mean value theorem, for example, for this guy here, says that the overall average rate of change, called the average rate of change, right? Average rate of change is from one black dot to another black dot, right? Whatever that is, whatever the slope of that is, there should be at least one point in between the black dots. So in between the black dots that has the same slope. So for example, we did this problem here. So overall, the average rate of change is from here to here. I think it was -1. You went down 1 unit or down 2 units over 2 units. So it was -1, right? So what the mean value theorem says is, as long as this guy is differentiable, has derivative in between, and it is continuous in between, there's going to be at least one point in between the black dots at which the derivative is the same as this here. And then we found, I think it was 1/3. 1/3 had the same derivative, the same slope. And I think -1 right at there had the same one. So that's what the mean value theorem says. Okay. Um, so the what was I going to say? Let's see. So that's pretty much what we've been working with, right? Um, so yeah. So the first thing we have to do is find the average rate of change, right? And then we have to locate where in between black dot and black dot is it also the same slope. All right. So we did a couple examples. Now let's look at number 3. Let's look at number 3. It says, okay, so for the function, sometimes they'll give you a picture, sometimes they won't. Okay, so for the function f of x is graphed below. So on your assignment, they will give you the picture. On this one, I didn't put the picture. Okay, so the first thing they want you to do is to show that you connected the dots. Okay, so when you're doing the assignment, that's what you're going to do first. Since there is no graph, we won't worry about that part. Okay, we're not going to worry about this part right now. Okay. Afterwards, determine all values of C which satisfy the conclusion of the mean value theorem for f on the closed interval, so less than or equal to, so that means it includes -6 and -3. Okay, so let me write this down. That's our interval there. All right, so the first thing we have to do is find the average rate of change. Okay, so do that right now. Find the average rate of change from -6 to -3. From -6 to -3. What is the slope? So when I plug in -6, I get -9. Is that what you guys got? And then when I plugged in -3, I got 7. So my two dots are -3, 7, and -6, -9. So average rate of change, I get 2 over 3, 2/3. Yes, they do some wrong.
Or f of -6
Yes.
should be a -5.
Should be -5. Are my numbers right, or did I multiply something wrong, or did I just do the last part wrong? Okay, so just the part is supposed to be -5. Perfect. Thank you. That's what I was looking for. Hoping someone would tell me what I did wrong, so that. Okay, so it's gonna be 12 over 3. All right. So 12 over 3, which is the same thing as +4. So rate of change, average rate of change from -6 to -3 is +4. Okay. So what we've done now is, this is a different problem, but essentially we've done is we found the slope of this line here. We found that slope. It's 4. It's +4. So again, it's not. This is not the problem, but it's just kind of a visual, because ours is going to be a positive slope. Okay, from -6 to -3. So now we have to figure out where along the function does the graph have the same exact slope. Well, if we're talking about a function and its slope, we got to find the derivative. Okay, so we get 3x squared plus 14x plus 4. Okay. And then what are we going to do with that? What are we going to do now? What's our next step? There you go. Set them equal to each other. Set the two things I found that I boxed equal to each other. So 3x squared plus 14x plus 4 equals positive 4. Solve it for x. I should get 2 answers since it's a quadratic. The degree is 2, so I should get 2 answers. So when we solve quadratics, we set it equal to 0 first. Oops, 14x. Okay, how do I solve for x? Again, when you're solving quadratics, you have 2 ways. You have factoring and you have quadratic formula. That's it. So luckily this guy is 2 terms, so you can factor out an x. Set everything equal to 0, so x equals 0. 3x plus 14 equals 0. X equals 0 already, so that's an answer. Don't have to do anything there. The next one I have to do is I actually have to solve it. So I'm going to subtract 14 from both sides. Divide by 3. And I get x equals negative 14 thirds. There are my 2 answers. All right. So those are my values of c, where I would have the same slope as I did from negative 6 to negative 3. I had a slope of positive 4 there. So we've got a couple questions we didn't ask, or we got to ask. Which ones are my answers? Are both my answers? Are one of them my answer? Or none of them my answer? Because on the test, this will be a multiple choice question, and they'll say that. They'll say A is 0, comma, negative 14 thirds. B is 0. C is negative 14 thirds. D, none of them. So which one would it be? Which one would it be? Divide? Yep, exactly. This is negative 4 and 2/3, right? So yeah, exactly. We go back up to the interval, and negative 4 and 2/3 is right in the middle. So that one works. But 0 is not in the interval. This is only negatives. So 0 is not in the interval. So 0 is not an answer that I would use. Okay. So the only answer that I would use is this guy here because it's in the interval. In the interval negative 6 to negative 3. And then the other question we didn't ask ourselves, we might have done all this for nothing. Just like the last problem we did on Friday, where you guys did a lot of work, but it was meaningless because we didn't ask ourselves these 2 questions. So is it continuous? Is the function you're looking at, is there anywhere where you wouldn't, where continuity is going to be an issue? Exactly, no, because there's no fraction. There has to be some sort of over 0 issue to be not continuous. So that's not a problem. And differentiable. Well, it's going to be differentiable. There's derivatives everywhere in between from negative 6 to negative 3. Anywhere I find a derivative, I'll always be able to plug in. That's what that means. So when you find a derivative, are you able to plug in a number and get an answer other than that? So essentially, these two are asking the same question. Would you ever plug in and get a 0 on the bottom? This one asks it for f of x. This one asks it for the derivative. Okay, so essentially they're asking the same question. If you plug in any number between negative 6 and negative 3, would you ever get anything that's undefined? So to figure out continuous, you find the limit of the original For differentiable, you find the limit of its derivative. It's the same procedures, but for different equations. Okay. And nope, we don't have an issue. So there we go. Negative 14 thirds. Okay, so I want you guys to do number 4 on your own. Do that right now. I'll give you guys about 5-7 minutes. Okay, so when I plug in 2, I get 36. Is that right? Is that what you guys got? And when I plugged in 7, I got 47. I did it all in my head, so I might have made a mistake. Mhm. Oh yeah, that's a good that's a very good question. Why did I do that? I don't know. I shouldn't have. So that's going to change this guy. So we get negative 24 plus 76, which is 52. Okay. 52. So then I would get negative 5 over 5, which is negative 1 for average rate of change from what is it, 2 to 7? Okay. All right. So now I need to find the derivative. So the derivative is going to be 3x squared plus 16x plus 4 minus 16x. Yes, minus 16x. Okay. I'm going to set that equal to the average rate of change, which was negative 1. Okay. It's a quadratic again, so I'm going to add 1 to both sides, set it equal to 0. We get 3x squared minus 16x plus 5 equals 0. Mhm. Oh, yeah, sorry. Yep, doesn't belong there. Thank you. Okay. Then I got a factor. So I'm going to get let's see here. The two numbers that multiply to be 15 and add to be negative 16 are, yep, negative 1. And then when I factor, I get 3x squared minus 15x minus 1x plus 5. I get 3x and x minus 1 minus 5. X minus 5, 3x minus 1. Set them both equal to 0. X equals 5, or x minus 5, sorry. X minus 5 equals 0, and 3x minus 1 equals 0. So then I add 5 to both sides, and I get x equals 5. and then I add 1 to both sides and divide by 3, I get x equals 1/3. So then I go back up to the top and see which ones. 2 to 7. So any of the C values that I found that are 2 to 7, well, that one right here is smaller than 2. It's less than 2. So the only one that I want is that one here. It's within the interval 2 to 7. Within. Okay. Okay, so the last thing I want to look at is kind of what we're going to be getting into. So we're nearing the end of this chapter. We're nearing the end. We only got a couple more things. We'll definitely be done this week with this chapter. But one of the things we're going to be looking at is what's called curve sketching. Curve sketching, where they give you some piece of information and you have to sketch a curve. Okay. So for example, 1, 2, 3, 1, 2, and 3. Examples 1, 2, and 3, Roman numerals. Those are all the originals. Those are all the functions here. The original functions, the f of x's. A, B, C are the derivatives, the f primes. So what they want you to do is figure out which one goes with which one. So number 1, if I were to find the derivative equation, or sorry, the derivative graph, which one would it be? 1, 2, or sorry, A, B, or C? A, B, or C. So number 1 here, the one I'm looking at right now, that's the original graph. That's the original, that's f of x. So if I were to find the derivative of that and then graph it, which one would it match? Would it match A, B, or C? Well, there's a couple different ways to do this. Okay? Depends on what type of problem they give you. So if you look at all of these, the easiest way to do it, if I look at this guy here, the original function, what degree would the original function be? And how do I know that? What do I mean by degree? I'll give you an example. What's the degree for the one we just did? What's the degree for this guy here, f of x here, the one we just did? 3. Yeah, 3. It's the highest exponent power. The highest exponent power right there. 3. Right? So let's go back down to the one we just looked at. Right. So we don't have an f of x, right? We don't have f of x equals, they don't tell us what it is. But if I did, what would the degree be? Yeah, why 2? It's a quadratic, right? Remember, quadratics are the ones that look like u's. They either look like that or they look upside down, right? But they're u's, right? So I know the degree here equals 2. So when I find the derivative of anything with a degree of 2, it's going to change to what? Exactly. It's going to change to linear, right? It's going to have to be a straight line. So you go over here and see if there's only one straight line. There is. Letter C. Letter C. Letter C goes with this guy here because it had to have been, has to be linear. It's the only linear one. Okay. Let's look at number 2. Now, number 2 is not quadratic, but it looks similar to something you've seen before. What does that look like that you've seen before? Looks a lot like sine, right? It looks a lot like sine, some variation of sine. We don't know how high it goes or how low it goes, but it looks like the sine curve. It starts out and does exactly the same thing as the sine curve, has the same pattern, right? Well, what's the derivative of sine? So we go over here and look for the one that looks like cosine. Lo and behold, it's this guy here. That guy kind of looks like cosine, right? So that one is B. And then the last one, what degree is this guy here? What degree, what functions look like that? It's not squared because it's not quadratic. But what, not it kind of looks like tangent, right? It kind of has that kind of same, but it's not it's not a trig function, but it kind of I know what you're saying. Hmm? Yeah, it's a cubic. Anything cubic kind of has that look where it increases and then kind of slows down a little bit and then keeps increasing. Or the opposite. Decreases, kind of slows down a little bit and decreases, right? Kind of that same look, right? Well, if I find the derivative of anything cubed, which I just did, right? We just found derivatives of things that cubed. They turned out to be quadratic. And there you go right there. Okay. So you can use process of elimination. You can use process of elimination to figure that out. Okay. So when it's matching, it's not too bad. You just kind of know, okay, well, what is it going to do? All right. We're going to be getting into that more this week, but I wanted to kind of give you just a preview of what we're going to be doing. All right. Okay. So what I want you to do now is grab the desk number Chromebook that goes with your desk. Grab that, and I'll post the assignment and let you get started. It's not a very long assignment, so you might even be able to finish it.